Hello, friends and students. So, in today's class, we'll make a small sensor, a very basic sensor, simple sensor. We'll make it, and I will tell you how to make it step by step. It will be a guide for you. So, first of all, what we'll do, we'll name that sensor. What we name, we should give this sensor. So, let's give the name to the sensor: bright light activated alarm sensor. Right? Using LM393 IC and 555 IC timer IC with a photoresistor on, you can see on your screen. So you can see on your screen here, one picture is there. This is the sensor which is available in the market right now. Okay, this sensor is called as LDR sensor, photoresistor sensor, or we call it as a light sensor. Right. So now what we are doing, we are making a new sensor, right? That is bright light activated alarm sensor. Sensor is there on the same PCB. What we are doing, we are adding a timer circuit on that, right? So by changing the value of the resistor, what value of the resistor? We can add a potentiometer, we can add a fixed value resistor that I will show you in the little coming circuits, and it will become a bright light activated alarm sensor. So this is a very simple sensor. We can, in the coming future, we'll try to make some other sensors also. Right. Now, what is the work of this sensor? The sensor will detect light intensity and output with the analog output. It will give you analog output only. Please remember, because we are using any 555. Okay. If any 555 is not there, then it can give you a digital output also, that is directly from LM393, right? So analog output, the light level crosses, if the light level crosses a certain threshold, right? Let's put some threshold to the light, like this much of lumens or lux. The output will get high or low. We can control the output high or low, and that high and low we can utilize for other application. That is the purpose of this sensor, or that will be the work of the sensor. Previously, this sensor, what you can see in the picture, according to the resistor, that is the LDR resistor, it will give you high or low, or either if it is in digital form, it will give you 0 and 1. But in this case, there will be alarm circuit. That is why we have kept the name as bright light sensor. Now, if suppose the digital output, if we want a digital output, we can also use digital output from the output LM393 as I told you, and the value can be displayed on the display. We can connect a display, and their value can be controlled, or the values, whatever. Suppose we can give threshold values of the light, this much minimum and that much maximum. For that purpose, we have to add another microcontroller for that. Okay. So probably then when we talk about microcontroller, naturally codes will come. So that we will see in the coming classes, but this is simple analog bright light activated alarm sensor. Okay. So we'll go to the next slide. As you know, what is light sensing? It will compare the voltage from LDR voltage divider and the threshold voltage set by potentiometer, that I will tell you in the lab. When the light intensity crosses the threshold, the LM390 output gets trigger, and the 555 timer that will be triggered to the 555 timer. What is the timer function? The second stage. The 555 timer generates a pulse of specific duration. When triggered, the pulse duration is determined by the RC network connected to the 555 timer. Right? We will connect a RC network to the 555 timer. That is, I will just tell you when we do the practical at that time, I will show you what are those resistor and all. And output is the 555 timer output drives the LED or buzzer. Output will be either we can put it a buzzer or we can put it LED or both for the duration of the pulse. Right? Duration of the pulse can be controlled. Please remember, that is controlled by RC. That is resistor and capacitor. Okay. So components required for this particular project: one IC, the LM393 IC, photoresistor you need 10 kilo ohms or 22 kilo ohm resistor you want, potentiometer of 10 kilo ohms you want, a preset, small preset, and capacitor, two capacitor we need, that is one is 10 microfarad and one is 0.01 microfarad. Other resistors we need 1 kilo ohm, 10 kilo ohm, 330 ohms, and LED, two LEDs or breadboard. Of course, we need buzzer also if you are using, and a power supply of DC 5 volts. Okay, so these are the components required for it. Now this is I have given a simple schematic diagram where two ICs are there, and you have to arrange this whole circuit on the PCB that you have to complete. Now one more important part about timer pulse duration is you should remember the formula for pulse duration. That is pulse duration, that is nothing but T is equal to 1.1 into R into CT. That is nothing but 1.1 into R into C. Resistor and capacitor has to be multiplied by 1.1 value. Then you get the timing. You will get what output? The timing. How long the light will be on, or how long the buzzer will be on, or how long the buzzer will be off. Both the things can happen, high or low. So I've just given you a small PCB. You can design a PCB. Please remember, while designing a PCB, try to design a dual-sided PCB. Why? Because it will be smaller in values. Like it will be smaller. Arrange the component on this thing and it should be smaller. So I will just repeat once again the steps, the components required. First step, second step, first you have to do is you have to make it on a breadboard, because you want to see the output. Because when you do some R&D work, please remember you should do it yourself, take the output, then go for the PCB. So first you have to assemble it on the breadboard, check the output. If you are satisfied, go to the next step, that is designing a PCB. How to design a PCB? You have a lot of videos. Probably I will also make some videos on how to design a PCB. You can make a double-sided PCB. My suggestion would be you make a double-sided PCB. Why? Because it should be compact and small in size. Then fourth, arrange the component on the assemble the component on the PCB with output connector pins, because you have to give the connector pins: digital output, analog output, supply pin, ground pin. This thing you have to do it. So these 4 steps you have to understand. Let's go to the lab and start working on the project.
Friends, students, so we have come to the lab. I will just show you the circuits. Just now we have discussed about the schematic diagram. The same circuit I have made it here. I will explain. This is your LDR. This is 393 IC. That is operational amplifier IC. You have a preset, that is nothing, variable resistor. And this is your timer IC. On timer IC, what I did is output. I have connected one LED to the output of the timer IC. That is for number 3. And what I did is I have connected one more IC, one more LED, which is just in between these two. That is, it shows the indication when high and low. Okay. So what are the connection? You can just trace it out. This is a bigger, I've made it on a PCB, but you can make it on a smaller PCB. I will just tell you, this is the PCB size. On this size only, you have to make this thing, because now you should not, PCB should not extend more than this. Okay. It should be more than this. So if you take a double-sided PCB, that is, the component should be on both the side. It is valid and good. Okay. Anyhow, so we'll come to this circuit again. So you can see the circuit. So I will give the connection first. Okay. You can see I will just try to give the connection first. So this is negative line. This side is a positive line. Both the supply. This is supply is approximately 5 volts. This works on 5 volt. Maximum of the sensors you will find which works on 5 volts. So I will just give positive supply to this thing, and you can see what has happened. Okay. Okay. So you can see when it is dark. When it is dark, I'm just putting my hand on the LDR and I'm removing it. You saw that this LED went away fast. That is directly, it is output is going to this LED, that is dark and light. And this is output of your, this is the output of your this thing. This takes little time. This LED takes little time. So why it is taking? Because we have used a monostable multi-vibrator circuit in this. That is 555 circuit is monostable. And we can change the timing. That means output timing, let it be a buzzer on the place of this, or let it be a LED. So we can change, that means after this much of time, it should be off. So that is, we can decide with the help of what? RC. I just told you before, RC. So this is C, this capacitor is C, and this is R. So 470 microfarad and 10K resistor, we can change the value and the timing will automatically change. Or in the place of this resistor, that is this resistor, you can place a reset also. So once again, please check. It is coming, right? I've kept my hand over there. I'm removing my hand. Immediately this got off and this is still on. It will take little time to switch it off. So this type of sensor you have to arrange on the PCB. This is the simple example of what we have made a sensor based project. Okay, sensor based, that is light dependent resistor with timer.